All right, so today we're going to go ahead and look at section 8.3. We're going to be examining a word problem. This is example 5 in your textbook, and we're being asked to examine the height of two water balloons. So the first water balloon is given by the function f of t is equal to negative 16t squared plus 80t plus 5. This represents the height in feet of the first water balloon after t seconds. T is a pretty common letter you'll see used as a variable, and it almost always represents time. Now, the height of the second water balloon is given via a graph. And if we look at our graph over here, we can sort of estimate the height. We'll have to check, to make sure that it is different enough from the height of the first water balloon that we can just use this estimate. But looking at the second graph, it looks like the height of this water balloon, it occurs right here where the vertex is. It looks like it's probably, this right here is going to be 125 because each box is 25 units. It looks like it's probably, I'm going to say it's around 130. So we're going to say the height, the maximum height, I should say, the second water balloon was about 130 feet. But now we need to figure out the maximum height of our first water balloon. And you'll notice that one of the things I said when we were describing our second water balloon is that I was talking about the vertex of the parabola. And our function that's given to us is also a parabola. It's in standard form. And because this parabola has this negative t value here at the beginning, let me underline that negative t value, or that negative value on the t squared. That's an a. That's the a value in our standard form, which, in case you've forgotten, our standard form is ax squared plus bx plus c. That a value ultimately determines whether or not the parabola opens up and down. Since the a value is negative, that means it opens down like it shows in the picture, and therefore it means it has a maximum value. If it opened up, it wouldn't make sense to talk about which water balloon went higher because one of them apparently slingshotted off into space, and as a result, will never get lower. So we need to find what the maximum value of our function is. And to do that, we first need to figure out what our vertex is. And in order to figure out our vertex, we're going to rely on one of the formulas, one of the very important formulas we learned in this section, which is x is equal to negative b over 2a. This is frequently called the formula for the axis of symmetry. The axis of symmetry, the x value that makes up the axis of symmetry, that vertical axis, is also the x value that's in the vertex, because the axis of symmetry has to go through the vertex because the vertex is the lowest to highest point that splits our parabola into two symmetric halves. So we're going to apply our formula. And if we look at the example that's given, our a value is that negative 16. Our b value is the positive 80, which is attached to the t, and our c is the 5. Although that doesn't really matter for this formula because c doesn't enter into it. So if we plug our values in, we have x is equal to, and our negative b would be negative 16. I take that back. Our b value is not 16 at all. Our b value would, of course, be 80. So we have negative 80 in parentheses. Underneath, we then have 2 times our a value, which is actually the negative 16. So make sure you're actually paying attention and don't do something foolish like I almost did. Anyway, negative times 80 would be a negative 80. And then 2 times negative 16 is negative 32. And then if we were to do this division, we would come out with 2.5. When we're talking about time, it's generally a better idea to actually use a decimal rather than a fraction. So that's the reason why I've chosen to use 2.5 here instead of perhaps what might seem more conventional for my choices in this class of 5 divided by 2. In any event, once we figure out the x value of the axis of symmetry, or the x value of the vertex, all we need to do at this point is plug it in, because the outcome the output is going to be our maximum height because we found the x value of our vertex. So if we plug that in, I'm going to go ahead and type this out because it'll end up looking slightly nicer, except not in red. We have f of 2.5, is equal to negative 16, parenthesis 2.5. All of our x's are being replaced by 2.5. I'll draw in the squared later, plus 80 times 2.5 plus 5. And then let me draw our squared in. Really ugly looking too. All right, from here, I'm going to use the calculator because I don't want to deal with this. Whoops, I did not mean to draw that over there. I'm going to use the calculator because I really do not want to deal with actually doing this calculation by hand. Because multiplying 2.5 by itself is, while not really that difficult, is kind of annoying. So for our first part, well, it's of course going to come out as evenly as it possibly could, because our first part, when you multiply negative 16 times 2.5 squared, you actually end up getting negative 100. And the way you do that calculation is 2.5 times itself, so 2.5 squared, 2.5 times 2.5, and then times negative 16. For our second part, we have 80 times 2.5, which gives us 200. And plus 5. And when we combine all these together, what we end up with is f of 2.5 is equal to 105. Now, interpreting this in the context of the problem tells us that the first water balloon only went up 105 feet because the output of this function is the height in feet and t is the time. So we can say that the maximum height of our second water balloon, or our first water balloon rather, and I just realized I misspelled balloon the first time I wrote it down, how embarrassing, was 105 feet, which we actually calculated rather than estimating. Let me change that because now it's really bothering me. Why did it? Okay, there we go. Now, the question was, which water balloon went higher? And the maximum height of the first water balloon, given by the function, was 105 feet, and the maximum height of the second water balloon was in the vicinity of 130 feet. So we can say the second water balloon went higher. And that's the problem. So the most important part of this problem was being able to figure out that our vertex was going to be our maximum height of our function f of t, which is something you could probably, hopefully figure out by looking at the example graph that was given to us. And then applying our axis of symmetry formula, plugging in the output of our axis of symmetry formula into our function, and then calculating our height.